in the first 9 days of our workshop, we have been always using the R script. You can see that the R script is a pretty basic way for us to start learning about R, because everything is in the same document. The R script is basically like a blank canvas where we can put all the code, all our annotation comments, and the results, the figures, everything is all in one place. But as we progress to learn more about R, you may find that this kind of organization may not be the most efficient, especially with the data all saved in data files that's isolated from the code. And when running some code, when running an analysis, the results will appear in the console, not directly under the code, and the contents in the console will be constantly washed off when you are running additional analysis. So you may wonder, is there a way that we can retain all the analysis output, all the figures, and also the data all in one place for us to better visualize everything all together, to help us better do research and also better share the results with our mentors or collaborators? So when it comes to sharing the results for the R script, you can also see we saved our data file in a summary folder in Excel or CSV or text format. So that is just for the descriptive stats or the analysis output. And for the figures, we had to print them separately into PDF files to save in another figure folder. And for the R script, we will also have to save it separately. And when we send those outputs to our advisors or mentors, they will have to receive a whole package of stuff with all different formats. And when they want to check our analysis code, they will also need to know how to use R, or at least have the R Studio installed in order to open the R script and read it. So all of these will add to the difficulty of sharing results and communicating science. And these will especially be difficult when we're communicating downstream to more junior career researchers, like undergraduate research assistant in our lab. If we want to share results with them, they will probably be overwhelmed with a whole package of different stuff, and even an R script that they don't even know how to launch it. So R Markdown that we're learning today is not anything new, but it's just a better way to organize and format our materials so that everything can stay together without being in separate files in different formats. This will facilitate us to organize our data analysis into a readable report and allow us to more easily share it with our collaborators and colleagues. Okay, so let's get started with that. I am going to share my screen. Okay, can everyone see it all right? Okay, good. So to begin with, let's first take a look at the R script that we used yesterday and see what's good about it and what are some potential drawbacks about R script. You can see that this is, as I said, is like a blank canvas. Everything is all together, and the text in the R script is basically like plain text without any way for us to format them to improve the readability. Like for the title of this script, it appears nothing different than a comment, and the author and the affiliation, they also not in any special font that can be centered or bolded or anything. It would be great if our script could be just like a Word document, and we can center maybe this part of the code, and we can just format the title differently. You can see that Nick tried very hard to format the titles for them to stand out by using uppercase letters and a bunch of equal signs. But these kind of tricks still don't make the heading appear very salient for you to realize immediately this is a different section than the following ones. And so this is one painful thing about R script. that it has very limited ability for us to format the text. And another drawback about R script is that all the code are intermixed together in the same script. And the way to run them would be depend on our manually selecting, highlighting different subsets of the components and run them differently. And sometimes if we just happen to highlight maybe missing a parenthesis or something, and you will encounter an error that cannot run through. So this is all adds to the difficulty of executing the code. And you can also see that because different parts of the code serve different functions, at the beginning of the code, we're just doing some background task that needs to be done at the beginning of every data analysis, like cleaning the environment, setting up the working directory and loading the packages. And these tasks only need to be done once at the very beginning, and we no longer need to repeat it ever again when working on the analysis. While in contrast, some other part of the code, like the actual data reshaping part, may need additional work while we're playing with the data. We may, for example, change the function from mean to median or to length at different occasions when we are analyzing the data in different ways. And when running this part of the code, we actually don't need to rerun the beginning, the background tasks, but having all the code put together in just one script. This will add to the difficulty of parsing different contents and trying to execute them in different ways, in different frequencies. So that's another thing. A little painful about R script. It's hard to organize the code, our code, differently and try to execute them in different manners. And the third drawback about R script, as I also mentioned a little bit before, is that when trying to see the results, for example, what if I run this entire R script, you can see that the data is not the results are not displayed directly in the same window we're currently looking at. But if we want to see accuracy average, we have to click on this data frame that's generated in the environment. And when we want to see RT average, I have to click on another data frame. And it will be somewhat difficult if you want to compare different data frames back and back. It's not easy to view them in the same window, and also the results cannot be easily retained in the same document. When saving them, we save them separately as text files in a different folder. And also when doing data analysis, say if we run this RT test, the results will appear in the console. But what if we run another accuracy t-test? What was there was washed away. Eventually will get lost in the history. So this is a little painful that we cannot compare several analysis results, view them together, and compare back to back. So R Markdown, as I said, is a solution to all of those drawbacks that I mentioned. It allows us to better organize the data without having all the important pieces scattered around the places. So first, for today's lecture, we're gonna first learn about some basic tricks about how to organize things in R Markdown, and that's the first half of the lecture. In the second half, we are going to work together to reorganize yesterday's R script, this full data analysis script, into a formatted, readable report that allows us to easily share the results and the conclusions in an interpretable manner with our collaborators. And to begin with, I think I will first share with you how the R Markdown file will eventually look like. So this is the knitted output of the R Markdown document I sent to you guys yesterday evening. And as you can see in the second half of today's, this is a table of content, by the way. displaying all the headings of different sections, allowing us to just easily go to different places along the report. And starting the second half of the lecture, we're going to reformat the full data analysis from yesterday. And here is just a preview of what the finally formatted report would eventually look like. Like when sharing with our collaborators, we may want to first add some analysis overview explaining what the purpose of the experiment is about and what independent and dependent measures we obtained in the data. And you can see that for different sections of the code, they're organized differently under corresponding headings. And the results, if we, for example, want to view how many trials each subject had in the data frame, that will be displayed directly under the section of the code that computes that. And for the outlier screening and participants' demographic information, we are also able to directly print out some concluding sentences in R Markdown to include the report without showing the very cumbersome big chunks of code that actually does the computation but provides no meaningful information to our mentors. And for the subject's descriptive statistics, there are ways to just directly print out the results under this part of the code that computes it for the descriptives to be included in the same document as the R script. And for t-test results, you can see that this is the classic t-test output that's also directly included under the t-test code. And if we find this output kind of difficult to interpret with all the different statistics intermixed together in a messy way, there are also ways to improve the readability by displaying the t-test table in this way, with different statistics extracted from the window. And there are also ways to automatically interpret the results from the statistical tests. There is an automated and lazy way of interpreting the t-test results, and there is also my custom function of interpreting t-test results based on whether it's significant and based on the direction of the effect, and that will automatically pull the statistics from the t-test. This will make it a lot easier for us when writing a paper. And for the figures, you can see the figure output will directly appear under the part of the code that does the figure, and the RT bar plots and the histogram will appear back to back in the same window for us to directly view different figures and compare them. So this is an R Markdown. This is just a preview of what we're going to accomplish at the end of the class today. By formatting your report appropriately and giving it certain content, certain elements, it will eventually become very readable, and it will be even friendly to undergraduate research assistants in our lab. If we send this report to them, they can view the results and know that you did a bunch of complicated analysis to produce the results. And this is also a way to, when we're turning in our assignments, say for your statistics classes, the instructor will immediately know that your code was able to run successfully from the beginning to completion and produce the corresponding output in the final knitted file without they themselves running your code.
That's probably one of the most useful utilities of R Markdown, and how people use it, I think, that I've seen that's really useful is that another way of thinking about R Markdown is if you're trying to do an analysis for yourself, R Markdown might be useful, but you might just use some of the tricks we've been doing in the class. But where I think R Markdown really shines is if you're trying to share your your output with someone else. It makes it more professional looking. And we've even had people do this with papers that we publish, that they share, some of their data analysis this way. So R Markdown can be really, really awesome, I think, for sharing stuff. It's just extra work to format the stuff to make it look pretty. So, but I think you can see you can make really, really beautiful summaries this way.
Yeah.
Just a quick question, how many people in the audience have actually ever heard of R Markdown or have seen an R Markdown script at some point? Okay. So it's a fairly common thing that you'll see. All right, I won't interrupt anymore.
Yeah, thank you. Another useful occasion for our Markdown, as Nick mentioned, is like when publishing a paper, we are always required to post our data in a public repository website. And nowadays, maybe some of you have already experienced, is that there's always an additional step after your manuscript has been accepted. A data editor will try to replicate your results to confirm that the analysis will actually produce results matching what you reported in the manuscript, just to double check, just in case there's any mistakes that incidentally gets published. And but if the data editor has to rerun your R script all over again, this will add to many technical difficulties. Like, what if they uses a different version of the R software that cannot run your specific packages? Or what if like you use some custom packages like the file merger we use in the CM arrow bars that we use today? Do they like ask us for the specific package? So that will just add a lot of extra unnecessary difficulty to them reproducing our results. So when I was publishing my paper, oftentimes the editor will ask me to submit the knitted output from R Markdown, like the one I'm showing you here, so that they know their R code would produce the corresponding output listed directly under the cut of the code without they themselves having to rerun them again. And this is also a way to like permanently reserve your results and permanently reserve this version of your R software output across the future many decades. Like, what if the R software keeps being updated and your current R code will not be compatible with the future R versions, and you won't never be able to rerun the code to produce the result again. But your R Markdown output will preserve all the results and code altogether. Okay, so this is just a preview of the final output and some useful occasions of R Markdown above and beyond R script. So let's get started today by opening a new R Markdown file, which is very similar to how we would launch a new R file. So if we click on this little icon at the corner of RStudio, when creating an R script, we just chose the first option here. But for R Markdown, we just scroll down a little bit and select R Markdown. And it will ask us to give it a name. So I'm just gonna call it R Markdown tutorial. And so a decision to make is what format of output we wanted to present. So one option is HTML format, which is the one I just showed you guys a moment ago. And another common option is PDF format. I think the differences is that for PDF, usually the texts are difficult to copy and paste it when you like try to reuse the code and copy the R code part to paste it in RStudio and run it again. Some of the formats will be lost or there'll be some bugs. So, but HTML format provides the greatest flexibility when sharing code. So if you want the audience who receive your R Markdown script to be able to rerun your code, you can share it in HTML format. Otherwise, if you want some better security of your code. You can share in PDF format. I'll choose HTML in most of the cases. And then click OK. So this will generate a R Markdown file for us. And as you can see, it's not an empty script like a new R script, but it has some like default demonstrative text and code from the R team. Janice, do you have a question?
Yeah, I was just wondering, like on the left side when you're creating it, it says like document, presentation, like shiny from template. Like what does that stuff do? Like when you're creating the R Markdown.
So I actually have never used those options before, but based on my understanding, for a document, you can like generate like typical document format, but for a presentation, you can do a PowerPoint. Yeah, you can make PowerPoint in R Markdown as well. And for Shiny, that is this one is mainly for coders. You want to share your code to allow people to perform some interactive things on your code. And I never explored this option before neither, but I'll say document is the most common thing.
Thank you.
Mm-hmm. Yeah, so you can see here's just the template for our Markdown, and you can see like the spaces is categorized into some gray parts and some white parts. Whatever is in the white parts is the text, and what's in the gray parts is the actual R code. So I see this as very similar to the organization of our brain. There are gray matters and there are white matters. And when R code is in the gray part, this is also like the gray matter where the computation and the information processing actually occurs. And what's in the white matter are just some text that serves to organize the computation and communicate the results of the computation. So that's just a fun example and an easy way to remember the function of different parts. For the white part, you can see that in an R script, we have to type a pound sign to begin with a text comment to just let the script know that this is a piece of text. It is not an R code, but in R Markdown, that is not necessary. Whatever is entered into the white spaces is automatically recognized as text. And if you enter additional pound signs, that serves to format the text in a different way. And for the R code, you can see the code chunk always begins and ends with some backticks and certain functions within a pair of curly brackets, serving to like run this code chunk differently than running this code chunk without that function. So these are just the ways to format and organize your R code differently. And we can try some examples, like if I create a code chunk here and I just say I just compute some mean participant ages, and I run this line of code, you can see the output will appear directly under the gray code chunk, allow us to directly see the results. Of course, it will also appear in the console down below. But say if I run another part of the code, the result in the console is washed away, but the result under the code chunk will be reserved, always appearing there without being replaced by the new results we just run. Molly, do you have a question?
Yeah, how are you creating code chunks versus text chunks?
Yeah, we will get into that in just a moment when we actually start learning about how to format things. Yeah,
Thanks.
that's a good question. Yeah, and any other questions? Okay, and I also want to show how to And you can see this document looks significantly different from the output document that I showed you guys. So this is just the source code of R Markdown. This is not the final output. And to produce the output, we just need to, we first need to save the document. If it's like a non-saved format, it wouldn't allow us to do that. So I'll just save it in as and when needing the results, we just click on this Need button here, and you can see that it will automatically generate a HTML format output in a new window, and you can see all the results from our computation and the one that's like by default from this template will all appear in a formatted report that looks much more prettier than the source code. And you may wonder, like, well, how can we find this report? So it will, after needing, all the output will be, will directly appear here. Like this is the .rmd, this is the source code that we just played with, and the output document in .html format will be using the same document name as the R Markdown file and will be generated in the same directory with it. And when we launch it, it will, you cannot see it because in a different window, it will appear in our default browser because it's in HTML format. And it will look exactly the same as what we just saw in the R window. Okay, so this is just some basic knowledge about how to create an R Markdown file, how to knit it, and where to find its output HTML report. And let's now return to our class material for R Markdown. And I am, in the first half of the lecture, I'm going to show you some tips and tricks about how to format the text, how to format the code, and how to run the code, how to create like code chunks, all the basic questions you may already have in mind at this point. And in the second half of this lecture, we can work together to reformat yesterday's full data analysis script into a more readable report format, like I just showed you at the beginning of the class. All right, so let's get started with it. You can see that here is just the R Markdown title, and if you would like a table of content like I showed you before to appear in the final output, you can just add this part of the code to the beginning. That will automatically create that. So in R Markdown, you can format the text in very flexible ways. Like for here, I just hand typed a table comparing R and R Markdown. You can see those are like really just some symbols that I typed, some hyphens, some vertical lines and empty spaces I hand typed into it. And when needing the file, this table will be formatted and automatically recognized into a pretty cool, well-formatted table comparing R and Markdown. So let's take a look at how R is different from R Markdown, and you may also wonder what Markdown actually means. So Markdown is a simple way to add formatting to plain text when you use certain like coding interfaces. Markdown exists not just for R, but for many other coding languages. It's a way to allow us to do formatting while coding. So what R script does, it basically just writes and runs R code. But for R Markdown, it allows us to format the text in a more flexible manner. It also allows us to display the output result together with the analysis R code. It also allows us to put figures directly in the document to stay together, to knit all the output files in one package when presenting it. And it also allows us to insert our result into concluding sentences, like those we would use when writing a manuscript. It can also need a very clean report in formats other than R that we can share with some more junior career researchers who do not use R. So these are the strengths of R Markdown compared to R. So I'm going to shut this window and keep using the source file. And you may also see that when trying to see what the output will look like, we always have to knit, and that by default will generate the output in a new window, which is not so convenient, doesn't allow us to see the source code and the output just in one window. And the solution to that is to change the output option. So I'm gonna do it now. It's in Tools, Global Option, and if we go to R Markdown, and we'll change the output preview in Viewer pane and apply. Okay. So now when I knit this document again, what you'll see is that it will appear in the Viewer pane of this lower right corner of the RStudio interface. This is this function is pretty useful when we're just testing our R script and see if it can really produce the output that we desire in real time. Okay, so as you can see, the content from both sides are like closely mapped with each other, and now we can talk a little bit more about how to knit the R Markdown file. So this R Markdown window is currently just the source document, and it will only produce the output when we choose knit. And then the format that it will knit the document into was chosen at the beginning when we created this script, but we can also customize the format when knitting it at different occasions by like knit to PDF or knit to Word if we want to try different formats. And let's also talk about some tricks about how to format text in R Markdown. The pound sign that we type in front of the text used to be like let the software know we're texting some comments that's not our code, but for here, the pound sign serves to let the software know that what's following it is a heading. And the number of pound sign will determine what level of heading it is. Like for the primary heading, we just need to type one pound sign, and you can see it appears in a pretty big font size. For the secondary heading, we use two pound signs, which after knitting will appear in a slightly smaller font size. And when using three headings, that will generate a heading in a even smaller font size. And you can see that here is a table of content also created simultaneously in real time as we enter the headings. You can see that the primary heading, the secondary heading, and the tertiary heading, they all appear at different hierarchy of indentation in the table of content. Those headings will help us to quickly navigate to different places in this R Markdown file. Next, we can also format text in R Markdown. Like when reporting statistics like p-values and t-values, we would need to italicize the letter. To do that, we can just type the text in between a pair of asterisks or a pair of underscores, and after knitting, they will look like this, being italicized. When we want to bold the text, we can use two asterisks or two underscores. And when we want to do bold and italicize, we can use like a combination of those different symbols, but use three of them that will bold and italicize the text. And in R Markdown, it is also possible to incorporate the R code within a sentence. Like if we want to instruct the users to use the library function to load packages, you can notice that I type the library function in between a pair of backticks. So this serves to let the software know that what's here is a R code, is not part of the text. And you can see that when knitting, what's in between the backticks will appear under a gray shaded area that looks different from the rest of the sentence. But R code in this format is not executed. In order to execute the R code, we will type a little r in front of the code. Like for here, the example is to compute the participant's mean age in a sentence. You can see that the R code is this part just to do the mean computation, but I included a little r and a space in front of the R code. This will, when knitting, it will automatically do the computation and display a number as a part of the sentence. It is also possible to embed hyperlinks in text. Like if you want to show to your audience like certain website you want to direct them to, for example, showing them like our course website is our workshop summer 2026 webpage. You can just do it by putting the links in parentheses and putting the text you want the link to appear under in this square brackets. And in the final knitted output, you can see they appear as clickable hyperlinks. And at this point, you may wonder, there are so many different tricks about R Markdown, and how is it possible for me to remember everything? The knowledge seems to be so trivial and so difficult to remember. The good news is that you don't have to memorize everything, but there is the official website of R provides a R Markdown cheat sheet for you to check for certain functions you are interested in. Like here is the website that you can look different things up in the cheat sheet. Next, in R Markdown, we're also able to format the text into a list format. Like if we just type a hyphen and a space, the text that following it will automatically be recognized as a list, and the hyphen will be knitted into a bullet point eventually. That's an unordered list. For an ordered list, we just need to hand type the numbers. This will make the content appear in certain order. And we can also emphasize different texts and structure them. For example, a simple way would be just to type a greater than sign and a space in front of a sentence. This will automatically add a special label in front of the text to make it stand out. And we can also insert a horizontal line in the Markdown window to segregate different sections of the file by just typing 3 hyphens. Those we needed will be recognized as a horizontal line. Okay, so that's everything about the text. Next, let's look at some tricks about how to format the R code. So first, you may wonder, how can you insert a code chunk? So there are some simple ways and some more complicated ways. One way is by manually typing, like if you type 3 backticks and R and also end by 3 backticks, that will be automatically recognized as a code chunk. But very few people would choose to type it manually. So an easy way to do that is to click on this green +C button on the toolbar and choose R, and you can see R Markdown also supports a whole range of different programming languages other than R. But for here, we just choose R, and a code chunk will automatically appear. And I also listed some shortcuts about creating the code chunk using buttons on the keyboard. Like for Mac, it will be Options plus Command plus R. That will just generate code chunks very quickly. A normal code chunk would just look like this, with just a little R inside the curly bracket, but nothing else. And when running it, we can either just click this green button. This will automatically run through everything in the code chunk. Or if there's just one line of code, we can also select it and hit Control and Enter. And if you want to run different chunks of code in the script differently in this document, a more flexible way to do that is to click this Run button, and you can choose to run the current chunk or the next one or all chunks above, which is useful when you want to establish all the preliminary conditions that is necessary for running the current code. Or you can choose Run All. That's the last option in the list, to run through this entire script. And after knitting this results of the code chunk, as we just showed before, it will appear directly under this gray area. So one thing important about the code chunks that we talked about before is that we may want to execute different parts of the code differently, depending on how important they are or what specific functions they serve. For example, sometimes we may just want to run the code and hide the code, only show the output to our audience. This may be useful when we are counting the number of males and females in our sample size, in which the code is not important to show, but we just need to show one concluding sentence showing the final head count of males and females. You can see to do that, I just added echo equals false in the little curly brackets. This will serve to run the code but hide the code, only show the output. You can see in the knitted file, the code is gone, but the output is still being displayed. In some other occasions, we may want to run the code but show neither the code nor the output. This will be useful for some background tasks, like setting up the working directory or cleaning the environment or loading the packages. So this code will not produce any meaningful output, or they may produce an error, like some packages may not be compatible with the current R version that we don't want to show to our collaborators or colleagues. So the way to do that is to put include equals false in the curly bracket. This will what this does is that it will run the code, but it will hide everything from it. Like you can see in the knitted output, there is nothing appearing under the heading. In some other occasions, we would want to show the code but do not run it. This may be useful when the code should only be run under certain conditions, like when installing a package. Installing a package is only necessary for the first time that you use this package. After installing, every time you just need to library it, but no longer need to run the installment code again. So in this case, you can include this part of the code in your document, just in case other people haven't installed this package yet. But you can use eval, which is short for evaluation, equals false, to prevent this chunk of code from being executed when you choose to run this entire script. This will be skipped. And to better distinguish different code chunks from each other, we can also name the chunks. The way to do that is also just to put some custom name in this curly bracket. And you can see once the code chunk is named, it will also appear in this table of content with a custom name. Whereas the other code chunks without a name will just be numbered, but not showing as anything special. Okay, so that's all the tips and tricks about formatting the plain text and formatting the R code in R Markdown. In the second half of this lecture, we're going to see how we can use our knowledge we just learned and reformat the data analysis script from yesterday. But before we move on, just want to ask, does anyone have any questions? Is there anything unclear in the first half?
Just a quick question. How did you show the table of contents? Just a second ago, you showed how you could name the different chunks, but we could see like the drop down. How did you show that?
Oh, you mean this one here?
Oh, it's down there. Sorry,
Yeah,
I missed you clicking on it. Thanks.
Yeah, don't worry. So this will be useful, especially when your R Markdown has hundreds of lines of code and you want to like go back to like check how can we set a text to be, say, how can we italicize a text? I forgot about that. I can just click on there. That will take me directly back to the place I'm looking for without me like scrolling all the way trying to look for it. And if I want to go back to the second half of the class about formatting our full analysis script, I can just click on that. That'll take me back here. Any other questions? Okay, so let's move on to reformat yesterday's full data analysis script into a more readable and interpretable and shareable report. So when sharing the data analysis results with colleagues, we may consider, before we move on, just to mention that R Markdown would also accept emoji entries, which makes it really useful to highlight certain things. Like with the emoji, this heading would definitely stand out from the list. It is easy for me to see like where the second half of the script will begin at. So yeah, use it to your advantage. So when formatting a report, we may want to include some text introduction about what this data set is about, what this experiment is about, and some basic information about the design, just in case the receiver of the script forgets about the design. So you can just include some basic information about this is a behavioral experiment, examine whether a salient singleton distractor would capture attention during visual search, and attentional capture is indexed by singleton presence cost in RTO accuracy. And you can also give like a preview of what steps are included in this data analysis, just reading the data, do some basic data cleaning, and inspect for outliers, and analyze reaction time accuracy, and eventually produce some t-test results and figures. Yeah, this may be obvious to us, but it's useful to include when sharing with other people. And so most of the code here were directly copied and pasted from the yesterday's full data analysis R script. And you can see this part is just the background tasks of cleaning the environment, setting up the working directory, and loading some packages. And you can see that I named it as setting up environment, make it easier to be found in this whole pipeline. And because these codes are neither necessary to be shown to our collaborators, nor that they will produce any meaningful output, I just use include equals false to prevent them from being shown in the final output. So you can see like this background task, which should be presented here if it appears is not shown in the final output. And you may also wonder, like, what if I don't remember what specific function to use to hide the code in the output? So an easy way is that if you click on this gear icon here, and you can choose the output option. It's currently chosen to be show nothing, just run the code. But you can also choose like to show output only. If I select that and apply, you can see it's automatically changed to echo equals false.
Jin, I have a question for you.
Mm-hmm.
So when you're making R Markdown scripts like this, you're not taking an R script that exists and referencing lines in an existing R script. You're just copying code over from the existing R script, like via copy and paste, right?
So at my current career stage, I no longer use the plain R script. I just have a R Markdown script that I can reuse for different experiments.
Yeah. I can see how that'd be very useful.
Yeah, and if you format it correctly, especially if you like are familiar like which part of the script you need to change for different experiments, it's really easy to reuse the R script for different purposes. And you just need to say, usually you don't need to change anything about the setting up the experiment section, but usually you just need to go down maybe to the data analysis section and do certain changes over there and be able to reuse it.
Got it. Totally clear. Thank you.
Yeah. And moving on, we next set up the data cleaning criteria. So I named it as criteria, and I currently kept it in the output just in case our mentors are interested in seeing what data cleaning cutoffs we used. And the next session is to read the data. I also copied and pasted directly from the R script. I chose include equals false, which will show neither the code or the output in the knitted document, because it's nothing. It's just resend the data. It's not important to show to people. And then here is something new that I added that's missing from the full data analysis script. This is when we want to like eyeball the data to see whether participants have, I guess I have to run it. I can choose to run, say, all chunks above to meet all the conditions that are necessary for me to run this chunk. So now it's runnable. You can see when I run it, it just presents like how many trials each subject has in the data file. It's easy for me and also for our mentors to like eyeball the data, see that the overall structure is okay. There's no data loss. But what if we have like 1,000 subjects, not just 7 of them? For 1,000 people, it will be really painful for us to like eyeball everything and check to see if it's always 600 for every single participant. So I also wrote some automatic R code here in the text to like automatically compute how many participants are there in the raw data set. I just used length unique subject number, and with the R for this part of the code to be executed, you can see that in the knitted data file, it says that there are 7 participants in the raw data this part is automatically generated from there. And I also wrote some code to automatically check, does every subject have the same number of trials? This is just by doing the length, whether like there is only one unique length in this column of the data frame. And if that's true, it will automatically produce an answer to this question. So we don't have to eyeball 1,000 participants' trial number manually. Next, moving on, is when we excluded outlier participants and outlier trials. This part of the code was copied directly from yesterday's data script, and I just added some additional R code trying to let the software decide for us whether there are any outliers and what subject numbers do they use, so we can identify them in the data frame. You can see this is just, I used echo equals false for this. That means this part of the code will be executed, but the code will be hidden from view, but the output will be displayed. So you can see when knitting, it only shows the output telling me these subjects are outliers, and if there's none of them, it just shows none. If there is anyone, it will display the individual subject number that are identified as outliers. And then for, so these things, I know that we are always able to do like manually, or we're able to eyeball the results if there are not so many subjects. But as time goes on, you will find yourself like spending a lot of time on this kind of easy tasks that's somewhat cognitively demanding, and you will make mistakes if you just happen to miss an outlier. So by doing it this way, it will allow you to very easily catch the outliers and never have to like worry about the little details in the code. So I suggest you always include some kind of automatic statement that saves yourself some time and effort if you have to do the task repeatedly in the future. So for the next part is the demographics. So I named this part of the code chunk demographics, and this is also something important only to like know the final head count of the males and females and mean age, but the code itself is not necessarily important to display in the output. So I just included a concluding sentence that will automatically count the number of males and females. You can see it tells me that the sample included 5 females and 2 males with a mean age of 23.1 years. And when knitting, this sentence will appear in the output, but the code is hidden. The next thing we did is that we reshaped the RT data by like trim it and make it into the long format, the wide format, and computed the singleton presence cost by doing the difference score. Yeah, these are all very useful computation, but in the R script, the results, the wide data format, the long data frame, they're all saved in the environment that we can only view them like when clicking on them. But what if we just want to show our collaborators about the basic descriptive stats for them to also get a sense about like the subject variations and if there is any visible trend that they can spot out in the data. So here I just added a line of code to generate a table for the RT wide data frame. So when I run this part of the code, it will produce a table summarizing the 7 participants' descriptive statistics. And when knitting, those will be formatted even more beautifully into a table displayed directly under this code. So with this, we no longer have to send the Excel file, a separate Excel file to our mentor for them to see the basic descriptive results. And moving on, we next did the t-test. Molly, do you have a question?
Sorry, just really quickly. I don't know if you can hear my vacuum. Sorry. Yeah. So if you run this NIT table and you have like 100 participants, it will output all 100. And then is there a way to do like a summary instead, or like a heading?
I think what happens if that's the case is that it will only show 10 people in a page, but there'll like be several different pages that you can click on. You can even click on here. So you click on page 10, it will show you from 90 to 100 there.
Thank you.
Yeah. So the next thing we did is that we conducted a t-test, and in R script, the t-test result will be put in the console and will be washed off if we run additional analysis. But in the R Markdown, if I like run this part of the code, you can see the t-test result will be displayed. It will be displayed directly under this part of the code. You can see in the knitted result, it's displayed directly under the t-test R code for us to see and re-see after we do other analysis. And if you find this format is not very convenient to see the statistics, you can also use a package called parameters, which helps to summarize the statistics in a readable table, and use model parameters function to reformat the t-test into a table. It will be reformatted into a table format that looks like this, with p-value, t-value, and degree of freedom formatted in a way that's easier to see. And when interpreting the results, what we typically do is we just see the value, check the values ourselves, and try to generate some conclusions. But if we want this process to also be automated, we can also use some packages to generate some concluding sentences based on the report. So the report package would automatically convert statistical analysis into some readable text. And you can just use report RTT test function to do that. You can see what's being generated may not be perfectly ideal for our purposes of writing APA-style papers. Like it says, the paired t-test, testing the difference between present and absent, suggests that the effect is positive, statistically significant, and large, and it produces a bunch of statistical values that may be useful for us. Well, it's good that it can correctly interpret the results as statistically significant and also evaluate the effect size to be large. But what it means for the effect to be positive, this doesn't make much sense. So I would say the lazy and automated method does not produce the most ideal output language that we need to use in manuscripts. But it may be helpful in some way, especially for the early career researchers, for them to interpret the results. But it's not ideal. What may be more ideal is to use some custom reporting languages that you can define by yourself. Like I just wrote some code to determine the statistical significance based on the p-value from the RT test results, whether it's less than 0.05 or greater than that. I assign a different label, and I also wrote some code to determine the direction of the effect based on whether the RT present and RT absent is which one is bigger. And you can see that here I included a concluding sentence myself, trying to explain the results, utilizing everything I defined before, which will eventually generate a concluding sentence that looks like this part after knitting the document. You can see that I first showed what test it is, so this part becomes a pure t-test shown in the conclusion, and this part is to interpret whether the result is significant or not significant, which it did correctly. And also it shows the t-values, so you can see here it uses the asterisks to italicize the statistics, which appear perfectly here, and attach the corresponding t-statistics values rounded to 2 decimal places here, and also attach the p-value, and if it's less than 0.001, I just display this rather than the actual value here. And I also made a directional judgment about in which condition RT is faster here. So if your experiments, always use the same experiment design, like doing t-test between the same 2 variables. You can write some kind of automated function to draw a conclusion that you can copy and paste into your manuscripts to save your time. Okay, do you have a question, Natalia?
Yeah, why doesn't the span style color section need to be in gray, like in the code part?
This part?
Yeah. No, the one right below it, the white section. Why is it coded, but it doesn't need to be in the a gray chunk?
You mean this part? Because it's text. Basically it will generate text, and the part of the code that's embedded into the sentence is put between a pair of backticks. That makes it recognized as code.
Okay, got it. Thank you.
I think is it correct too that you're using the span style equals color magenta? That's actually HTML, isn't it, rather than R?
Yeah, this part is, yeah, you're right. This part is HTML. There might be some more appropriate ways to do the coloring in R, and you can look it up in the R Markdown cheat sheet provided. There's a website linked earlier in this document. Okay, so those are just some convenient ways to do the RT analysis. Just to summarize, some specific things that we did in R Markdown that was not done in R was that we printed out some concluding statements about whether there are any outliers and some head counts of males and females. And we were also able to eyeball the descriptive statistics, and we converted the t-test results into a more readable format in a table for us to see. And we can also generate some automated concluding sentences to help ourselves in the future when writing a manuscript. These will all be very useful and save you time, especially if your studies use the same design and similar features repetitively, and you can just make very minimal changes to your R code to be able to reuse them. And the accuracy analysis, it follows the same logic, so I'm just going to skip it for here. You can just make the same changes to accuracy, the same as what we did to RT. And finally, here is the figure sections. You can see the figures are always important to view, so I added some emojis for it to be easily spotted in the table of content. So yesterday, to save the figures, we first had to open up a PDF file in order to save the figures, and then we plotted the figures. Eventually, we had to use this part of the code to close the PDF file. This will make the whole process kind of cumbersome, and also requires like manually opening and closing the PDF files, and the figures will eventually be saved as separate PDFs that when we are like sharing the results, we have to share separate elements. That makes it complicated. And fortunately, these problems are all solved in R Markdown. We can just generate the figures directly in the same report as the R codes. You can see that when I run this part that generates the bar plot and the histogram, this part is just copied directly from yesterday's code, except the part that opens and closes the PDF file. You can see it produced two the bar plot and the histogram directly under the code chunks. And when knitting, the bar plot figure would appear directly under the bar plot code, and the histogram figure would appear directly under the histogram code section. So this allows us to visualize both figures directly and like compare their differences back and forth to see if they are consistent. And when sharing, your like mentors and collaborators will be able to like also see the figure in the same document as the t-test results. It's just easier to compare everything back and forth. So yeah, this is probably everything I have about R Markdown for today. Does anyone have any questions? Or is there anything unclear you want me to show again?
Well, if there aren't any questions, feel free to stick around if you have a super specific question that you don't want to ask in front of the class. After lecture, Jen and I will hang out just like we always do after class to answer special questions that people may have. Same if you have questions about what you want to do next or how to move on from here. Thank you, Jen, for showing us R Markdown. I think you can see that R Markdown is a really, really useful tool for making kind of beautiful data summaries that are easily shareable with your colleagues. So I think R Markdown is really, really helpful. I would also say to beginners, if you're worried and it seems like, this is a whole new skill that I'd have to learn to do coding, it's not mandatory to use R Markdown. R Markdown can be convenient in certain ways. It is a little bit of extra work and extra things to learn. So if you're just trying to get started, and you feel like maybe R Markdown's too much, you don't have to do everything in R Markdown. That's why we saved it until the end rather than building the whole course around it. That being said, R Markdown can be really useful for sharing data summaries with colleagues, including like online. It's also really useful. I think a lot of people who make online tutorials are using R Markdown to show stuff. So if you get on, you're doing some kind of ggplot2 tutorial, they're probably almost certainly using something like this. So I think having some knowledge of how to use R Markdown would be a good thing, or at least being familiar with it conceptually is good. And I think it'll make things easier, especially if you're trying to share stuff with other people. So it's definitely one of those things that's optional, not mandatory, so don't feel overwhelmed by it, but it is a great sort of tool to have at your disposal.